Something is out there. In the vast, silent darkness between the galaxies, a signal has been found. It's not a message from aliens. It's not a new star exploding. It's something far more fundamental. Something that whispers about the very fabric of reality itself. The 3i Atlas project, a silent sentinel scanning the heavens, has detected an anomaly. An irregularity so profound it has sent ripples of shock and excitement through the scientific community. This isn't just another discovery. This is a crack in the mirror through which we view our universe. It challenges the very laws of physics we hold dear. What we thought was empty space is not empty at all. It is alive with a structure we are only now beginning to perceive. Imagine the cosmos as a great dark ocean. For centuries we have studied the islands of light we call galaxies, mapping their shores and charting their movements. We assumed the vast waters between them were just that, water, an empty, passive medium through which everything travels. But the 3i Atlas discovery suggests something else entirely. It tells us that this cosmic ocean has currents, unseen structures, hidden pathways. It hints that the universe might be interconnected in ways we never dared to imagine. In times of great scientific upheaval, we look to voices that can guide us through the complexity. We seek out thinkers who can bridge the gap between arcane equations and human understanding. One such voice belongs to Dr. Michio Kaku. He is more than just a brilliant theoretical physicist. He is a visionary, a futurist, and one of the world's most gifted science communicators. As a co-founder of string field theory, he has spent his life wrestling with the deepest questions about the nature of reality, exploring the possibility of higher dimensions, parallel universes. His work pushes the very limits of what we consider possible, venturing into the theoretical realms where science and imagination meet. Dr. Kaku's credibility is built on a foundation of rigorous scientific inquiry, combined with an unparalleled ability to make the complex simple. He doesn't just talk about science, he invites you into it. He paints pictures with words, using analogies that connect the strange world of quantum physics to our everyday experiences. When he speaks, presidents, industry leaders, the general public listen. They listen because he has a proven track record of foreseeing the trajectory of technology and science. He understands that a new discovery is not just a data point. It is a seed that will grow to reshape our society, our technology, our philosophy. His perspective is essential. His expertise is not confined to a single narrow field. Dr. Kaku possesses a sweeping, interdisciplinary view of science. He fluidly connects the dots between theoretical physics, cosmology, artificial intelligence, the future of humanity. This allows him to see the bigger picture, to understand how a discovery in one area, like the 3i Atlas findings, could trigger a cascade of consequences in another. He is not afraid to speculate, to push beyond the confirmed data and explore the what-if scenarios that drive scientific progress forward. It is this combination of deep knowledge and fearless imagination that makes his warnings so compelling and his insights so valuable. So, when a discovery as monumental as the one from 3i Atlas emerges, the world turns to Michio Kaku. We want to know what it means, not just for the scientists in their labs, but for us, for our children, for the future of our species. He is our interpreter, translating the complex language of mathematics and cosmology into a story we can all understand. He provides the context, the caution, and the sense of wonder. When he raises an alarm, it is not out of fear, but out of a profound sense of responsibility. He understands that with great knowledge comes the great responsibility to use it wisely. His warning is a call to pay attention. So what exactly did the 3i Atlas project find? In the simplest terms, scientists discovered a network of massive, previously invisible structures stretching between galaxies. The project's full name, Intergalactic Infrastructure Investigation, Advanced Terrestrial-Based Large Area Survey, designed to map the empty space that makes up most of the universe. Using a new form of deep space imaging that measures subtle gravitational distortions and faint energy signatures, the survey revealed filaments. Think of them as colossal cosmic bridges or threads, connecting galaxy clusters across millions of light-years. These are not made of stars, not gas, not dust. They appear to be woven from dark matter. For decades we've known that dark matter exists. We can't see it, but we can detect its gravitational pull on the things we can see, like stars and galaxies. It's the invisible scaffolding that holds galaxies together, preventing them from flying apart. We thought of it as a diffuse, mostly uniform halo surrounding galaxies. But the 3i Atlas data paints a radically different picture. It shows that dark matter is organized. It forms a vast, intricate network, a cosmic web. The galaxies we see are like bright beads of dew that have condensed along the densest intersections of this web. We have been living inside a structure we never knew was there. The discovery was made by painstakingly analyzing tiny fluctuations in the light from distant quasars as it traveled across the universe to reach our telescopes. This light, on its journey of billions of years, is subtly bent and distorted by the gravity of whatever it passes. The 3i Atlas team developed algorithms sensitive enough to map these minute distortions on an unprecedented scale. What emerged from the data was not random noise but a coherent, repeating pattern. A pattern that revealed these colossal filaments of dark matter, forming a sort of superstructure for the universe itself. It's a discovery as fundamental as learning the continents on Earth are connected by a hidden tectonic system. This finding is a triumph of technology and perseverance. The 3i Atlas project combined data from multiple observatories around the globe, synchronizing them to create a virtual telescope the size of the Earth. This allowed for a resolution and sensitivity that was previously unattainable. The team of scientists spent years sifting through petabytes of data, refining their models and eliminating all possible sources of error. What they were left with was an undeniable conclusion. The universe is not a collection of isolated islands in an empty void. It is a single, interconnected entity, bound together by an invisible web of immense proportions. We are not just in the universe, we are part of its very structure. Amid the excitement, Michio Kaku's voice rings out not with panic, but with a profound and necessary caution. His warning is twofold, touching upon both immense opportunity and potential risk. First, he emphasizes that these dark matter filaments are not just passive structures, they are likely regions of extreme and exotic physics. The immense gravitational forces and densities of dark matter within these cosmic bridges could create conditions that exist nowhere else. They could be cosmic accelerators, capable of flinging particles at energies far beyond anything we could create on Earth. They might even be gateways, areas where the fabric of space-time is warped in extreme ways. Kaku's primary warning is simple. We do not understand what we are looking at. To interact with these structures, or even to probe them too aggressively with high-energy signals, could be like a child poking a hornet's nest with a stick. We do not know the rules of this new domain. He speculates that these filaments could be unstable. Sending a powerful energy beam into one could, in a worst-case scenario, trigger a cascade of unknown effects. Could it disrupt the gravitational balance that holds galaxies together? Could it unleash a wave of high-energy radiation? His point is not that these things will happen, but that our ignorance makes recklessness a profound danger. To truly grasp the significance of the 3i Atlas discovery, let's use an analogy. Imagine you are a tiny ant living on a single leaf of a giant tree. Your entire world is this leaf. You can see other leaves on other branches, distant and separate. You assume the only way to get to another leaf is to fall off your own crawl across the vast empty ground and climb up a new tree. It's a journey so long and perilous that it seems impossible. Your science, the science of an ant, is based on the reality of living on a flat, isolated leaf. This has been our perspective of the universe for all of human history. Now, imagine one day, you develop a new kind of sense. You realize that your leaf is not isolated. It is connected to all the other leaves by a network of branches, twigs. You were living on a tree the whole time and never knew it. This is what the 3i Atlas discovery has done for us. Our galaxy, the Milky Way, is a single leaf. The other galaxies are the other leaves. The dark matter filaments are the branches and twigs that connect everything. We suddenly realize we are not on an island, but part of a vast, interconnected structure. The empty space we thought we had to cross is actually a network of pathways. This changes the rules of the game. For the ant, realizing it's on a tree opens up entirely new possibilities. It can now travel from leaf to leaf by walking along the branches, a much faster and more direct route. This is the opportunity Michio Kaku speaks of. If we can learn to walk along these dark matter filaments, we might find new ways to travel or send information across the cosmos. The journey between galaxies, once thought to be impossibly long, might have cosmic shortcuts we never knew existed. The universe, in a sense, just got a lot smaller and more accessible, at least in theory. But this analogy also illustrates Kaku's warning. The ant doesn't understand the tree. It doesn't know what a branch is made of, or what happens if it chews through one. What if damaging a branch causes the whole section of the tree to wither and die, including its own leaf? This is our situation. We have discovered the cosmic branches, but we have no idea how they work. Our most powerful actions are like a tiny ant's bite. But as our technology grows, our bite will get bigger. Before we try to manipulate these cosmic structures, we must first understand them. We must be like wise ants, studying the tree with respect and awe before trying to re-engineer it.